February 20th, 1943, north of Kasserine Pass, Tunisia. The official battle reports could never truly capture the site that morning. German tank commanders watched in disbelief as American Sherman tanks executed maneuvers that defied all established Wehrmacht doctrine tactics, simply considered impossible without constant visual signals. Through the blinding dust and smoke of the North African battlefield, 5 Sherman tanks, completely separated by broken terrain and without a line of sight between them, converged on the German positions with supernatural timing. There were no signal flags, no flares, and no dispatch riders frantically racing between vehicles. Yet, they moved with the seamless precision of a single organism, each tank covering the blind spots the others couldn't see, every crew member knowing exactly where their comrades were positioned. Inside their own Panzer IVs, equipped with the Fug 5 radio system, German commanders struggled to hear their company leaders through the wall of static that overwhelmed their amplitude modulation AM sets. The 10-watt German transmitters, cutting edge by 1,930 seconds standards, couldn't reliably penetrate more than a few hundred meters when the tanks were on the move. Crucially, most German tanks were equipped only with receivers. They could hear orders, but were unable to report what they saw or call for help. The Americans, however, were operating with a technology the Germans didn't even know existed. They used frequency modulation, FM, radios, in every single tank. This technology provided crystal-controlled precision, a massive 25 watts of transmission power, and a voice clarity that sliced through engine noise and the surrounding battlefield chaos like a knife through paper. 8,000 miles from Detroit's assembly lines, the most decisive technological advantage of World War II was revealing itself not in the thickness of a tank's armor or the caliber of its main gun, but in the invisible electromagnetic waves that networked every American tank crew in ways the Wehrmacht had never conceived. The birth of the battlefield network. This transformation began on July 22, 1941, when the U.S. Army standardized the Signal Corps radio sets, the SCR-508, SCR-528, and SCR-538, for installation in all medium tanks, while German forces pushed deep into the Soviet Union, relying on rigid radio communication solely between command vehicles. American engineers at the Galvin Manufacturing Company, later known as Motorola, were perfecting the FM technology that would render German systems obsolete. The team included Daniel E. Noble, who first conceived of applying FM technology to military vehicles, and Henryk Magnoski, the principal RF engineer who solved the monumental technical challenges of installing sophisticated electronics into the harsh, vibrating environment of a tank. Their creation, weighing 181 pounds, fundamentally transformed every Sherman tank into a node in the world's first battlefield network. The BC-604 transmitter generated 25 watts of power, 2.5 times the output of the German Fug 5. Operating in the 20 to 27.9 MHz frequency range, it offered 10 preset channels with crystal-controlled stability. The dual BC-603 receivers within the SCR-508 allowed commanders to monitor multiple frequencies simultaneously, a capability that would soon prove decisive in combat. The real game-changer was frequency modulation itself. Edwin Armstrong's patented FM technology, licensed to the military, virtually eliminated the static and interference that perpetually plagued German AM systems. While German tank radios picked up every electrical discharge and ignition spark as ear-shattering noise, American FM radios delivered crystal-clear voice communication, even through the din of an intense artillery barrage. Superiority revealed, North Africa and Italy. November 8, 1942, Operation Torch brought American armor to North Africa. The tanks of the 2nd Armored Division landed near Safi and Fedala, equipped with the SCR-508 radios that would soon demonstrate their overwhelming superiority over German communications. The Afrika Korps, despite being the Wehrmacht's most experienced armored force, operated under severe communication limitations. A standard German tank platoon of 5 vehicles included only 1 or 2 command tanks, with full Fug 5 transceivers, capable of both transmitting and receiving. The rest carried only Fug 2 receivers, which meant they could hear orders but were powerless to respond or report enemy positions. German tank platoons were forced to function through a rigid hierarchy. The platoon leader transmitted orders, and subordinate tanks acknowledged through actions rather than words. When command tanks were destroyed, easily identified by their multiple antennas, the entire platoon instantly lost coordination. This proved catastrophic against American forces, where every single tank could assume command functions. The Battle of Kasserine Pass, February 14–24, 1943, provided the first major demonstration of this American radio dominance. Though technically a German victory, the battle revealed capabilities that stunned Wehrmacht observers. During the confused fighting, scattered elements of the U.S. 1st Armored Division maintained coordination across 50 miles of the battlefield. Tank crews who had never met coordinated attacks warned each other of threats and called for artillery support, all thanks to the crystal-clear FM communications. German signals intelligence units intercepted the American transmissions and noted their exceptional clarity and coordination. The 10th Panzer Division's intelligence section reported that American units maintained communication at ranges where German radios produced only static. Even more disturbing was the realization that every American tank appeared capable of full transmission, not just designated command vehicles. The German Fug 5 radios, operating on Amplitude Modulation, AM, in the 27 to 33.3 MHz range, suffered from fundamental limitations. The 10-watt transmitter struggled to reach 2 to 3 kilometers in ideal conditions, plummeting to mere hundreds of meters when the tanks were moving. Every firing spark plug, every electrical motor, every track movement generated interference that the AM systems simply could not filter. September 1943 brought American armor to Italy, where the mountainous terrain should have negated radio advantages. Instead, FM technology proved even more valuable in conditions that rendered German AM radios useless. The SCR-508's frequency modulation capably handled the multipath interference of mountain valleys far better than amplitude modulation. American tanks coordinated movements through terrain where visual signals were impossible, and German radios failed completely. During the advance toward Cassino, American armored units demonstrated a coordination that defied German understanding. Tank platoons, separated by entire ridgelines, coordinated attacks with a precision that German doctrine insisted required visual contact. The 1st Armored Division's after-action reports described routine coordination at distances where German radios produced only static. The Network Conquers Europe, June 6, 1944. As Sherman tanks rolled off landing craft at Normandy, their SCR-508 radios maintained contact with naval fire support, a coordination impossible with German technology. However, the hedgerow fighting, bocage, immediately revealed a critical gap. The tank radios couldn't communicate with the infantry radios, the SCR-300, which operated on a different frequency range 40–48 MHz versus 20–27.9 MHz. This communication gap proved deadly in the bocage, where German infantry with Panzerfausts could approach American tanks, while nearby American infantry had no way to warn them. American ingenuity solved the problem within weeks. Tank crews quickly mounted EE-8 field telephones in ammunition boxes welded to the tank's exteriors, wired directly to the internal communications system. By Operation Cobra in late July, this simple field modification had revolutionized tank infantry cooperation. July 25–30, 1944. Operation Cobra demonstrated the full potential of American radio superiority. The 2nd Armored Division, commanded by Major General Edward H. Brooks, coordinated over 200 Sherman tanks through radio networks that enabled unprecedented battlefield control. German defenders from the Panzer Lehr division faced an enemy that seemed to possess supernatural awareness. American tanks responded instantly to threats reported by other units miles away, and artillery strikes coordinated through tank radios arrived within minutes of target identification. The contrast with German capabilities was stark. Panzer Lehr, once Germany's premier armored division, had been reduced to communication poverty. Most of its tanks operated without radios, depending on visual signals in terrain where visibility rarely exceeded 100 meters. The few functioning radios suffered from interference and limited range that prevented any effective coordination. The irony of German failure. The irony was profound. Germany had pioneered radio use in armored warfare. Heinz Guderian, the architect of Blitzkrieg, had insisted on radio equipment in tanks since the 1920s. His book, Achtung Panzer, 1937, emphasized communication as absolutely essential to armored operations. Guderian understood that rapid armor advances required reliable communication, yet, by 1943, German tank production could not provide the radios Guderian's own doctrine demanded. German production statistics revealed the crisis. In 1943, Germany manufactured approximately 5,700 medium tanks, but fewer than 2,000 Fug transceivers. Many radios went to command vehicles and assault guns, leaving regular tank units desperately short of communication equipment. Soviet tank forces suffered even worse communication poverty. The T-34, despite being the most produced Allied tank, typically entered combat without any radio equipment. Soviet doctrine relied on flag signals and pre-battle planning, with catastrophic results against German forces in 1941. By 1943, Lend-Lease provided some relief, with American radios, including SCR-508 sets, equipping Soviet command tanks. But even by war's end, only about 25% of Soviet tanks carried radios. The comparison highlighted the staggering American achievement. While the Soviet Union struggled to equip 1/4 of their tanks, America achieved 100% deployment of sophisticated FM systems. Motorola's Chicago factory represented American industrial mobilization at its peak. Before the war, the company manufactured car radios. Converting to military production required complete retooling and solving unprecedented technical challenges. Each SCR-508 required 2,748 individual components manufactured to exacting standards. The BC-604 transmitter alone contained 474 capacitors and 385 resistors. Crystal oscillators had to maintain frequency stability, despite temperature extremes and combat vibration. Production statistics told the story of American industrial might: 3,800 units in 1942, 11,400 units in 1943, and 24,000 units in 1944, a total wartime production of over 50,000 tank radio sets. This production miracle ensured that all 49,324 Sherman tanks manufactured during the war received sophisticated radio equipment, an achievement no other nation approached. The unseen advantages. The SCR-508's advantages went far beyond simple frequency modulation. Crystal-controlled frequency stability meant tanks could preset channels before battle and maintain alignment despite combat conditions. German Fug 5 radios, using variable capacitor tuning, constantly drifted off frequency. The dual receiver configuration allowed commanders to monitor their platoon net and the company command net simultaneously. Orders flowed down the chain of command instantly, while commanders maintained full awareness of subordinate situations. The BC-606 intercom system integrated seamlessly with the radio, allowing all crew members to alert the commander to threats. Throat microphones and noise-cancelling headphones enabled clear communication during the loudest combat. Many German tanks lacked intercoms entirely, forcing crews to communicate by touch or shouting. Power management provided another American advantage. The SCR-508 operated on either 12 or 24 volts, automatically adjusting to available power. The dynamo motor power supply provided stable, filtered power that eliminated electrical interference. German radios, powered directly from vehicle electrical systems, picked up every spark as static. The tactical advantages of universal radio deployment transformed American armored doctrine. The combat command structure, flexible task forces organized for specific missions, depended entirely on reliable communications. American commanders could create ad hoc battle groups from different units, confident they could coordinate through compatible radios. This flexibility baffled German commanders, who were accustomed to rigid organizational structures necessitated by limited communications. During the Battle of Arcourt in September 1944, the 4th Armored Division faced multiple German panzer brigades equipped with superior Panther tanks. The Germans had every advantage in armor and firepower, but American radio coordination proved decisive. Every Sherman could report enemy positions instantly. Tank destroyers received targeting information from tanks they couldn't see. Artillery observers in Sherman command tanks called in devastating barrages within minutes. Over 3 weeks, the 4th Armored destroyed 281 German armored vehicles, while losing only 41 Shermans, a 7-to-1 kill ratio that defied technical specifications. Intelligence, failure, and final victory. Throughout the war, German intelligence failed to grasp the significance of American communication superiority. Combat reports mentioned American coordination, but routinely attributed it to training rather than technology. A captured September 1944 intelligence assessment stated, "American tank units demonstrate good radio discipline and coordination. This appears to result from extensive training and rigid communication procedures." The report completely missed the technological advantage. German tactics never adapted to American capabilities. They continued targeting supposed command tanks based on antenna configurations, not realizing every Sherman could coordinate battlefield responses. They planned ambushes, assuming American tanks would lose coordination when separated, not understanding that radio contact maintained unit cohesion regardless of visual contact. March 1, 1945. As American forces approached the Rhine, their communications superiority reached its zenith. The capture of the Remagen Bridge demonstrated the speed of American command and control. When the 9th Armored Division discovered the Ludendorff Bridge intact, radio reports reached 1st Army headquarters within minutes. Within an hour, divisions across the entire front were shifting to exploit the opportunity. German forces, dependent on vulnerable telephone lines that American aircraft systematically destroyed, couldn't respond with comparable speed. American radio coordination created an impenetrable defense of the bridgehead. Tank platoons from different battalions integrated seamlessly, coordinating fires through radio networks. German counterattacks, poorly coordinated due to communication failures, arrived piecemeal and were destroyed in detail. April 1945. The encirclement of the Ruhr Pocket demonstrated the culmination of American communication superiority. American armored columns from the 1st and 9th Armies coordinated a complex double envelopment entirely through radio communications. Inside the pocket, 325,000 German troops found themselves trapped, partly because their communications had utterly collapsed. American fighter bombers, guided by radio-equipped forward air controllers, systematically destroyed German communication nodes. Wehrmacht units lost contact with higher headquarters and each other. Field Marshal Walter Model's final messages before communication failure revealed the German plight. No contact with adjacent units, no communication with higher headquarters. Fighting continues, but coordination impossible. The enduring legacy, American radio superiority, profoundly affected the psychological experience of tank warfare. American crews fought with the knowledge they were never alone. Even when physically isolated, they remained connected through radio waves. German tank crews experienced the opposite: profound isolation. Unable to communicate, they fought individual battles within larger engagements. After Germany's surrender, American technical intelligence teams evaluated German equipment. Their findings confirmed what combat experience suggested. German tanks often possessed superior armor and armament, but catastrophically inferior communications. A U.S. Army Technical Intelligence report concluded that German tank communications equipment was approximately 5 years behind American systems. The absence of frequency modulation, limited radio distribution, and poor electrical suppression created critical vulnerabilities. Soviet evaluators reached similar conclusions, choosing to copy American radio designs rather than German systems for post-war development. The final statistics highlight the magnitude of the American achievement. The radio superiority of Sherman tanks established principles that govern armored warfare today. Modern main battle tanks carry communication suites that trace their lineage directly to the SCR-508. The German Bundeswehr, rebuilt in the 1950 seconds, prioritized communications based on World War II lessons. A Bundeswehr training manual explicitly states, "The defeat of superior German tanks by inferior American vehicles with superior radios teaches that information dominance outweighs platform superiority." The story of American Sherman tank radio superiority represents a victory in the electromagnetic spectrum that proved more decisive than any advantage in armor or firepower. German tank crews fought their war partially blind to this revolution, discovering too late that every Sherman tank was not just a fighting vehicle, but a node in history's first battlefield network. The SCR-508 radio transformed the M4 Sherman from an adequate medium tank into a component of a weapons system that included every other American tank on the battlefield. Whether accurately quoted or apocryphal, Field Marshal Wilhelm Keitel's reported comment at Germany's surrender captured a fundamental truth. "We knew how to build better tanks, but you knew how to make them work together." America had built not just 49,324 Sherman tanks, but 49,324 nodes in the world's first armored battlefield network. The revolution in military affairs began in 1942. The connected would overcome the isolated. This invisible advantage determined victory more surely than any visible superiority in armor or armament. The Sherman tank's radio superiority changed warfare forever, establishing the principle that in modern combat, connection equals survival and isolation equals defeat. February 20th,